Okay, it looks like we have a pretty full room, so it looks good, and we welcome you. And thanks for attending the Basic Estimating Guidelines and Building Complexities of Insulated Metal Panels. I am Jeff Irwin. I am the Executive Director of the Insulated Metal Panel Funders Group. I know that's a mouthful. We are a privately funded group within the Metal Construction Association, and our main mission is to increase the use of insulated metal panels through education, marketing, technical support of code and standards. And which brings us here today. Our course is today is basically trying to define down on the basic estimating guidelines, points and purpose. And also, we tied into this the actual different types of buildings. Because in that, a lot comes out of how much labor, how do you unload it, and so forth. I'm not going to steal the presenter's thunder, so we'll move on. Give you a little background, the Metal Construction Association, which you may or may not be aware of, is co-owners of MetalCon. And last year they asked us to get involved and do a course on insulated metal panels. And it was best practices of installing and basic estimating tips. After the course, we were approached by, I was approached by 4 or 5 people from different companies saying, why didn't you drive down more on estimating points, facts, and guidelines? And I said, well, you can't do everything in an hour. So therefore, because of that request, we put together this course for everybody's benefit, and we thank you for attending. I think you'll find it's going to be very rewarding to you. Just a couple housekeeping points. We ask that you hold your questions till the end, or questions or comments, because we welcome comments as well. I will be walking around with a microphone so that you can, everybody can hear your question, and to make you aware, this course is being recorded. Also, are there any architects in the room? Just raise your hand if we have any architects. Okay, because this course is also approved for continuing education units, so wanted to ask that. Another thing that we're all very fortunate for this year is the fact that we have 3 expert presenters. All experts in the industry, all members of our group. Starting off, we have Kim Harrell of All Weather Insulated Panels out of Vacaville, California. Following up with him will be R.C. Antle from ATAS out of Allentown, Pennsylvania. And following up the rear, and our cleanup hitter today is Brad Gilmore from Centria out of Pittsburgh, Pennsylvania. A little private joke. So with that, and no further ado, I am going to bring up Kim Harrell.
Good morning. So how many estimators, just by a show of hands, estimators in the room? So the purpose of today is not to try and reteach estimating 101. That's not the purpose. But we do want to try to describe some of the differences that are unique to insulated panels. They're kind of their own animal. And we want to just point out a few of the things that are unique to insulated panels that you may not see in other types of materials that you're putting up, single skin or otherwise. So we're going to go through some estimating basics. My job is to just go over some of the basic, and then we're going to turn it over to RC and Brad. They're going to talk about different building complexities specifically, and maybe give you some things that you can be aware of as you're looking at drawings, because not all projects, obviously, with insulated panels are the same. And you guys know the capabilities of your own companies and what you guys are capable of bidding and executing. So we're going to try and walk you through some of that this morning. If you're sitting here, I'm sure you know what an insulated panel is, but in the event that you do not, take a look at this.
Composed of 2 sheets of cold-rolled galvanized steel and an advanced polyurethane foam core, IMPs provide a pre-manufactured perfect wall. This metal and foam composite construction creates a rigid panel far stronger than the individual parts.
When you look at an insulated panel, you're talking about an interior liner sheet, insulating core, and an exterior sheet all in one step. So when you're taking one lap around the building, you're drying in the building, insulating it, and lining it all in one step, something that's unique to our product. Also, inch for inch, the best insulation you're going to get, polyurethane insulation is inch per inch, the largest insulation value you're going to get. Normally, insulated panels are used for those reasons, for insulation efficiency and also construction efficiency. That's why you would use them. When you're estimating one of these jobs, I would say you probably only need a handful of drawings when you actually go to bid an insulated panel job. We all know how large drawing sets can be. When you're looking at insulated panel jobs, plan views, floor and roof plans, elevations, sections, and then there's some details that may help. We'll just go through these really briefly just to show you the information that you can get off of this. Elevations are useful because they'll tell us where the panel locations are. A lot of buildings you'll see mixed use. You'll see some brick, you'll see some metal, you'll see some stucco. Elevations really help us visualize where the panels are going on the building. It tells us where the sight lines are in the building, where the roof lines are. So elevations are useful to sort out where the panels are in the building. And then also elevations in many drawing sets will give us the actual height of the wall. That's where I'm going to pull off. The wall heights, also if my panels are sitting on top of something else. Also really good to see where you have openings, penetrations in the building, large door openings, louvers, windows, that kind of thing. Elevations are going to tell you where those are. Dimensionally, roof and floor plans are going to tell you the dimensions roughly of the building. So you're looking at a floor plan, you're going to get the footprint of the building. If you're looking at a roof plan, you're going to get the roof plan dimensions themselves. So dimensionally, I'm going to be able to pull the height of the building off my elevations. I'm going to be able to pull my building dimensions, my wall dimensions off of the plan view. And that's very simple. Now, I may need to drive down into some details. I may need to look at some sections to determine if insulated panel is going to go full behind. Maybe there's a facade of brick. Maybe it's going to go full height, whether it's sitting on top of something else. So sections are going to help tell me some things that maybe elevations and plan views can't. So I'm going to look at some wall sections from time to time just to give me an idea of how the panels lay out with regard to other types of materials. Then I can drive down into some details. Details are going to tell me specific connections, how specific connections are made, how I'm putting corners together, where corners are making up with other types of materials. So just those handful of drawings are going to help me a lot. Plan views, sections, elevations, and details should give me all the information I need to be able to come up with quantities of jobs. Now, with any material, you're going to have some weathering surface on the building, and you can always double check yourself against some raw weathering surface. You have a 10,000 square foot surface area wall. You're going to need 10,000 square foot of material on that wall, and we're going to talk about that a little bit more. One other thing that's useful is if you have in the drawing set, if you have renderings of the project, renderings can sometimes be very helpful to visualize where the materials are going to go. Sometimes an architect will give you the color changes on the building. You can see if there are multiple colors on a building, things like that in architectural rendering. So that's going to be really helpful when we talk about where the panels are going to go with regards to other types of materials on the job and also color changes on it. So we talk about determining panel quantities. There's some things that are specific to insulated panels we want to talk about. Let's just say a 10,000 square foot building. You're going to obviously need 10,000 square foot of roof, but it's never going to be exactly 10,000 square feet due to things like slope gains and gutters and soffits and all kinds of other conditions. When you call an insulated panel company and you want a quote on 10,000 square feet of roof, just understand that there's always going to be additional material, and we're going to talk about some of the reasons for that. So 10,000 square foot of roof is not going to always take 10,000 square foot of roof panels. It's usually going to take a little bit more than that for reasons we're going to talk about here in a second. There's reason for drop. You're going to buy a panel that's 36 inches wide or 40 inches wide or 42 inches wide. You're going to have to cut that panel at the end. You may have some angles. You may have some dormers or some crickets. You may have a lot of different conditions up there that are going to create drop. You're going to have roof slope. The steeper the slope is, the more material you're going to have to add for that. And you're going to have to do things called cutbacks, which we're going to talk about here in a second. We're going to talk about a little bit about doors and window deducts. We typically don't recommend any deducts for small 3070 personnel doors or small windows because those are going to be field located, and you're going to normally be cutting those out from full width, full height panels. So we typically don't take any deduction for small openings, and we're going to talk about just taking the correct percentage for large openings. So the kind of stuff we're going to talk about in the next few slides. Looking at an elevation, looking at this wall, and determining where the panels are going to lay out on the wall. Something that's different about insulated panels than, let's say, a 12-inch or a 16-inch wide single element panel would be that when you're talking about 40 inches or 42 inches, you're covering a lot more area with a single panel. And as you step a panel down the wall, all of those little triangles that are going to be created up there are going to be dropped. Those are going to be scrap. But you're still buying that. You're still buying that panel from the manufacturer. So this drop needs to be accounted for. If we were laying this job out with our own drafting department, we would probably only step this job every 3 or so panels to give you a little bit more flexibility in the field. So even when we draw it ourselves, we tend to create a little bit more scrap and a little bit more drop than maybe you would. So insulated panels, by just the nature of the width of the panel and giving yourself some flexibility, you're going to actually create more drop with insulated panels than you normally would. Unless your building just happens to land exactly on a module, you're always going to be cutting either a starter panel or a final panel when you get to a corner. So with wall panels, make sure you're adding for the full height of those panels where you need them. Allow for a little bit of extra scrap and drop when you're cutting, especially along rake walls like this. On a roof, we have some special conditions when we deal with insulated panels. When you're putting up a traditional standing seam roof or an R-panel screw-down roof, metal roof, you're going to be overlapping those panels. Same is true of an IMP. The trick with an IMP, though, is there's going to be a piece underneath that panel in an end lap condition. It's a little bit of a square. It's about 6 inches to 8 inches, depending on your slope, that needs to be removed. This little area that's shown in blue, actually, you're paying for that 6 inches of panel, even though it's overlapping. You're going to remove that piece. It's called a cutback, a roof cutback. On a very large roof, you may have several of these. On a small job, probably not the end of the world. 6 inches times the length of your building, maybe 1 or 2 sides. You may be only talking about a few square feet to a few hundred square feet. On a large project, if you have 1,000 feet of building and you have 6 inches of drop per side, you just came up with 1,000 square feet of panel that you're going to be purchasing, but it's not covering surface area on your building. So things like this you want to take into account. Same thing is true when you get to the eaves and the gutters. If you come to the edge of your roof, you're going to have a full panel going out, and you're going to have to remove the same piece. There's a little bit of a cutback at the gutter. Depending on the manufacturer, depending on the detail, you're going to need to get all the way to the outside of your wall panel, and then you're going to have to allow for your gutter as well. So there's a 5-inch to 9-inch sometimes piece of panel that you need to account for. So if you take both of these things into consideration, if you look at the roof quantity and you look at the cutbacks that are at the middle of the roof in the field, and you take into account what could be happening at your eaves, a general rule of thumb, and this is what I would recommend, something when I was in the field and I was estimating panels, on a large roof, on a very large roof, I would add 5%. That usually covers me for my slope gain. It usually covers me for my drops, for my end laps and my gutters on a large roof. On a smaller roof, you may want to add up to 10%. So this takes, you send an estimate, and we have an estimating department at our place, and many of the manufacturers do. You'll send them in an estimate, and you'll have a 5,000 square foot roof, and they'll send you back an estimate that says 5,500 square feet. And you say, no, the roof's only 5,000 square feet. And they'll explain to you, well, because of the eave conditions and things like that, you are going to have 5,500 square feet. This is a good rule of thumb when you're estimating, and it's something that you can use, especially because I know if you're like us, you don't have a lot of extra people around your office. You're probably bidding a lot of projects, and you don't always have the time to invest in really noodling out a job and really determining what the exact square footages are. So this is a good rule of thumb you can use. 5% for large roofs should cover you well. It should cover you well, and 10% for smaller roofs. And it allows for that drop that's created just for end laps and eaves. So that's the roofs. Again, we're going to have some question time afterwards if you have any questions on this kind of stuff. For the walls, when we talk about openings for walls, the interesting thing is, how do we treat a small window or small door versus a large opening? Large openings, this is just a real detail views cut out of, let's say, like a 10 by 12 door, 12 by 12 overhead door. remember, as you look at where these panels are laying out, if it's a small window, 4x4, it's a 3070 door, never deduct that panel, because what's going to end up happening is you're going to get full panels there, and you're going to field locate that door, and you're going to cut that out. So if it's a personnel door, or if it's a 4x4 window, that's going to come out with full sheets. Just like you're looking at this wall to our side, you're going to have full sheets, and you're going to cut it out. So you're going to be buying those sheets full. If I'm looking at a 12x12 door, though, you can kind of see how those panels lay out, and you can see above the panel, above the door opening, there are 3 panels that are short. When you're doing shop drawings on this kind of a job, you can actually allow for that, and you can only purchase the panels that are above that door. In any case, though, you're going to have some panels that are going to run down the jambs of that door that you're going to be buying full panels. So when we look at this, an aggressive deduct for this, let's say it's a 12x12 door, that's 144 square feet. That'd be the full deduct for the full amount. I can't take that because I'm going to have some panel running down each side. An aggressive deduct for that would be 120 square feet that I take out. And let's just say you have a long set of dock doors. That's a lot of material. And if you take out 144 square feet for every one of those doors, you're going to be light on your estimate, because ultimately you're going to have some panels that are going to create kind of hockey sticks. You're going to have cutouts of those panels on either side of your jambs. The safe deduct would be to take only about half of the amount, in this case about 80 square feet from that door opening, and then you're going to allow yourself to do that. So again, like we had on the roof panels, a conservative deduct for openings, for large openings, is about 50% of the opening itself. So if you have, this is if you're doing an estimate where you don't have guidance from a manufacturer. Maybe you're having to put a bid together in a short amount of time. These are safe, conservative estimates that you can use when you're taking those door openings. So on a 144 square foot opening, a safe deduct for that would be only take about half of that. And you're going to allow yourself enough to have panels on either side of that door. So that's quantity stuff. Quantity stuff that relates to insulated panels, important because we have just some unique things about our panel. Where an insulated panel is going to need to have some foam removed and have some overlaps done and things like that, may not be true of other types of material. So there's some things that are unique about our material. Other things that are unique would be the cuts that you have to make when you do doors and windows. So that's quantity type stuff. Now, what are some other factors that go into the price of a panel? Now, recognizing different manufacturers have different price points for everything. This is general and is true for all manufacturers. We're going to talk briefly about special colors and finishes, gauges, facings, small quantities, special metals, things like that. The dollars up there are similar to the way you look at menus in restaurants. Single dollar, a little bit of money. $3 signs, a lot of money. So when we talk about things like special colors and finishes, we're going to talk about ways of affecting this. Looking at to value engineer a project would be to stay on the standard colors and gauges. It's every manufacturer has a standard color palette. They do that for a reason. It allows us to stock material on our floor. It reduces lead times. It controls our costs, so we can control cost to you guys. One of the biggest factors that increases not only cost but also lead time in getting material is special colors and finishes. When you look at custom reds and custom blues and custom greens, depending on the time of year, we all deal with similar supply chains, even on the single element side of our business. Coil coaters have certain lead times to get us material. Paint companies have certain lead times to get material to the coil coater. So we're talking about in the neighborhood of between 6 and 12 weeks just for us to get raw material to make a special color. That's after the special color has been approved. The owner, you're working with an owner, and he wants a blue that matches his wife's eyes or whatever, so then you go out and you find the color, and then you turn the color chips around, and everybody finds the right color, and then you send it to us. We have the color matched. All of that just takes time. So all the manufacturers will probably tell you the same thing. We can do whatever you want to do. If you give us enough time and enough money, we can do anything you guys want us to do. Now, if it's like any other construction job, there's not all the time in the world and there's not all the money in the world. So try and stay on a manufacturer's standard color chart. Try and steer your owners, try and steer your architects back to a manufacturer's standard color chart. There's a reason we have them. Gauges are the same way, gauges and facings. When you talk about going from 26 gauge, that's something that's unique about our material. Most manufacturers can make an insulated panel in 26 gauge, and it lays flat. It looks really good. 26 gauge single element material may not look that way, so you're typically used to automatically going to 24 gauge. Maybe not necessary with an insulated panel. So go with your manufacturer's suggestions, manufacturer's guidelines for the gauge and facings of the panels. You don't automatically have to bump those facings. Going to 24 gauge is 15 cents a square foot. Going to 22 gauge is 45 to 50 cents a square foot. Just adding the gauge of material, it may not be necessary to do that. Small quantities, always going to be a challenge for an insulated panel. We make large quantities very well. We can make 100,000 feet of panel very effectively. It's the way our lines run, the way our continuous manufacturing process goes. What we don't do well is we don't do one panel well. We don't do one panel well. So when we talk about small quantities, I think it would be good to say this. In your estimates, always allow a couple extras. I would say allow a couple extras of the longest length wall panel, longest length roof panel, always. Because here's a secret. There's never been a job ever built in the history of construction that something doesn't happen. And it may not be your guys. It may not be you miscutting something. It may be another trade that doesn't recognize that that's finished material, so they need a ladder against it, or someone backs a truck into the corner of the building or whatever, and now you need two panels. Well, the other thing that's true is the job is never close to the factory, and it's never a standard color or gauge. So it's going to be far away, and it's going to be a special color. So now we're going to have to run the job special, and we're going to have to put it on its own truck, and we're going to have to ship two panels to you very far away. So now your two panels that you could have bought in your original estimate for a couple $100 now turns into a couple $1,000 because you're putting its own truck under it, getting it there. So better to have a couple panels on the job site that you may not need. You probably will. For some reason, you probably will need them. So always take extra. So small quantities are going to cost money. Small quantities are going to cost money. That would include, when you look back at that rendering and you go back to that, when you go back to that job and you see the architect has drawn 15 different types of panels in 3 different widths, you can simplify the job for me. Say, hey, how about if we just go to 3 colors and a couple of widths, and we can get these runs up to a place where a manufacturer can actually make this for a reasonable amount of money. Manufacturers, some manufacturers are set up really well to run small quantity special colors, and others of us, it's going to cost considerable money when the job is really cut up. So you can steer architects and owners into combining quantities. It's another way of kind of a value engineering a job. Anytime you go to special metals, stainless steel, aluminums, things like that, it's going to cost a lot of money. It's going to cost a lot of money. Stainless steel is popular in food service and in cold storage side of our business. It's $1.50 a square foot per side to go to stainless. Never put stainless outside, by the way. Stainless is only an interior application. Aluminum's also expensive. And like we said before, multiple panel types and panel widths are also one of those things that adds to cost. We are not, as a manufacturer, I'm not the best person to talk to as far as labor goes. But I can tell you some of the things that do affect labor from our perspective. When you talk about an insulated panel, nothing is going to install faster and nothing is going to dry a building in quicker than an insulated panel on a steel frame. It is a very, very efficient way to build. But sometimes special equipment is needed to lift big panels. If you have very, very tall panels, 40 footers, you're going to need to bring in some suction lift equipment, or you may need some cranes, things like that. That's going to require some special equipment that gets brought into the project. You're not going to be able to muscle up a 40-foot panel. You're just not going to be able to. Panels are going to be 2.5 to 3 pounds a square foot. Not uncommon for panels to be 300, 400, 500 pounds a piece. So you're going to need some special equipment. Take that into effect. It will affect the cost for the material. It won't affect the cost of material. It will affect the cost of your labor. The special equipment that you bring in is obviously going to help you on the labor side. And today, in today's market, labor is driving everything. Labor is driving everything. Labor is very expensive. So special equipment and things that you can bring in to help you on the labor side, even though it may seem like a big price tag, renting a suction lifter or whatever, it's going to help you on the labor side for sure. Site conditions, sometimes you have a nice clean layout area. The picture on the top, I've got access all the way around the building. I can lay my panels out. I can stage them around the building. I can install efficiently. And then sometimes I just have a giant mud hole. And I've got to lay my panels out. I've got to fight the job site the whole time. Those things are gonna really affect job site conditions. So far we've just talked about some of the basics. We've talked about the material itself, determining panel quantities on buildings, things that IMPs are specific to, more drop than you're used to when you're working with other types of materials. We talked about things that affected panel price, special colors, special gauges, special facings, things like that. Small quantities are going to really drive that cost. So now, and we talked about some of the labor things. You're going to have some special equipment that you may need. It's going to ultimately save you labor, but you're going to put that in your estimate, and you're going to have some site conditions that are going to be challenging for you. So some of those things that are special to insulated panels. I'm going to turn it over to RC from ATAS. He's going to walk you through the first set of slides. It's going to talk about the actual complexity of insulated panels and the way the jobs are. So RC, I'm going to bring you up. And when RC is done, he's going to turn it over to Brad. So from now on, we're talking about job-specific stuff, and these guys are going to steer you in the right direction as far as how we look at jobs and how we look at drawings and taking a job from the drawing stage through construction. So.
Excellent job, kid. Thank you very much. Name's R.C. Antel with ATAS International. And as Kim said, we're going to look at the different complexities of buildings. I'm going to be doing complexity A today. So when we look at complexity A buildings, they're typically low-rise, typically pre-engineered. I'm going to say box buildings. So when we look at this panel layout on this building here, we can see everything's a vertical application. So it's running from the knee wall there up into the bottom of the soffit of the building. So when we're looking at it, we're looking at panel layouts, as Kim went over, taking into consideration full panel widths, and then also looking at the man doors on there, the windows, and then also the large garage D doors. So one thing that we really want to focus is on the doors. So when we look at the man doors and also the windows, we're not going to deduct for those. We're going to assume full panel widths through there. They're going to be scrap in the field. However, on the large garage doors there, as Kim discussed, we're going to remove for them. So if you look at the large garage doors, on each side, the left and right side, we're going to run full panel widths. But in the center of it, we want to do a conservative deduct there, allow ourselves for some extra scrap, but we can really just order the panels that are above, not assuming panels running through those garage doors. Also, we want to look at canopies there. For example, in this building, the canopies are actually proud of the insulated panels. So the insulated panels run behind the canopy there. You're going to have basic trims on this building. You're going to have your base detail. You're going to have your jam details, your head details. When you look at the top there, where these panels, they actually bury behind a soffit. So if you have coping or if you have a fascia or they're burying up behind a soffit, you don't have to worry about your panel lengths as much. You don't have to be exact because the panels are actually going to run up and tuck behind there. So overall, relatively simple, consistent layout. It's not a very complex layout. Once again, we want to review it's low-rise, typically pre-engineered, and also more of a box design. Now let's take a more in-depth look at the building. You can see standard pre-engineered metal building. You can look over here and you can see running full panel lengths. Now the cutouts here for the doors and the windows, when you would typically order full panel lengths and then just cut and remove in the field. Now for the garage doors, you can see here, this would require a full panel length and the panel is actually being notched. So if you were to order that panel to there, you would actually be short. Now, when we talk about deducting here, we could deduct and just order panels from here, panels from here. However, you have to be careful when you look at shop drawings compared to actual site conditions. For example, if this was to move over, if the building was to move over slightly, and you only ordered a panel to there, you would actually be short. So it's a big consideration when looking at these. You want to have overages. The last thing that you want to do with insulated metal panels is be short. Kim had talked about that during the manufacturing process. To order 1, 2, 3 panels, you don't want to do it. It would be cheap insurance to have extra panels on site, so if a condition changed. You can see the interior of the building where the finished liner and the panels are being attached directly to the girts of the building. Also, you have your basic trims, your jambs, your heads, your base trims there. So overall, relatively simple layout. For a contractor that's looking to get into insulated metal panels, or even for an experienced metal contractor, this is the type of building that you want to go after. Now here's the finished product. So along the edge here, you would have your base details. The panels are actually running up, getting tucked behind those soffits there. So if you're a little short or a little long on the panels, you're okay because it's hidden. Now, if you had different buildings, when we get into the category A or category B, panel lengths, you have to take much more consideration. These canopies are proud of the insulated panels, so they actually run through it. And then you have your basic trims that are running around the building. So relatively straightforward, easier install and application. Now let's move forward to roofs. So we're going to look at complexity A roofs. So when we look at the top of the roof here, this is a clear story, and it looks like it would almost be full panels. It's not. So we want to identify on the drawings that, okay, this is actually a separate roof than the other 2 lower roofs. Now when you look at the layout, relatively short panel lengths, that makes for easy install. Also, it's a straightforward design. There's not valleys and hips. We have your standard ridge. Now you will have a head wall detail here, and we will show that in a second, but relatively straightforward with your panel lengths and your panel layouts, and really basic trims. You know, you're going to have your ridge, your rakes, your eaves, and that head wall detail in here, but you know, relatively simple, straightforward layout. Now, when we look at the inside of the building, you can see that clear story here. So here's the ridge, then you have your panels, and then here's your lower portion of the roof. Now here's the finished product. You can see the panels on top of the clear story there. You have your ridge, your rakes, and your eaves. There's your head wall detail, and then once again, straightforward panel layout coming down, and then your standard rake and ridge. So this would be for insulated metal panel roofers that are looking to, you know, get into roofing, or metal contractors that are looking to get an insulated panel roofing. This is relatively straightforward. We don't have, you know, panels coming down, going into valleys, hips, trying to change direction of water flow. This is typical A-frame roof, very straightforward. And this would be the type of buildings that you would want to go after if you were just getting into the insulated metal panel business. Now, furthermore, let's recap. So we talked about a couple things, typically like a low-rise building, pre-engineered often, and often box design. So you can see here, for example, the insulated metal roof, vertical insulated metal panels, areas for deduct where we have rows of garages, windows and man door, we would run panels straight through, relatively straightforward basic trims. Building over here, all vertical panels, more vertical panels with large garage doors and man doors, and then a school project, but once again, vertical panels, standard trims, your jambs, your head, your sill details. Layout is typically consistent. You'll notice the colors on there, maybe 1 or 2 colors, larger quantities. We're not getting into the smaller quantities, relatively straightforward design. So that would be a summary for the Category A type of buildings. Now we're going to turn it over to Brad, and we're going to review the Category B and Category C buildings.
Good morning. Thanks, RC. So looking at a Category B building, this is going to be more your industrial, commercial. You're going to have a mixture of horizontal, but mostly are going to be vertical panels on these applications. Larger buildings, sometimes multi-stories, big boxes. For example, here, this is an airport or a hangar. And looking at these projects, you see there's a lot more ins and outs. In this situation, there's soffit panels that go up in here. You have an office area, you have the high hangar bay. So you got to keep in mind, these elevations wind up being hidden on the elevation drawings. So you wind up, as you're doing that takeoff, you got to make sure you account for those. So using the floor plan, like Kim had talked about earlier, making sure you walk yourself around the building. You'll notice too that we accounted for the waste factor because of that slope. Now granted, we did the takeoff with this green area with that large triangle there. It's a big job that gives us a little bit extra scrap. And same thing up in the upper portion of the roof area. Panel through all the louvers, and then we have the doors that are located in the different color. One other thing to keep in mind on these projects, in complexity B, you got to look at your wind loads. So you're actually going to need to pull the structure drawings on these projects. So it's a little bit more complex to make sure that you are spanning from girt to girt and proper fastening patterns. There may be an opportunity that your panel's wide with a long span that you have to back fasten. So always take that opportunity to look at those structural drawings to get your loads and load span tables. The manufacturers can always help you with those load span tables. So to recap a little bit on complexity B, simple jobs, not too complex. You can see a roof with some minor details. These little bump outs here, these were add-ons after the panels were installed. So not too overly complex, but bigger jobs, a few more ins and outs to remember. Complexity C, this is going to be your high-end architectural. This is going to be large complex office buildings, convention centers, stadiums, very intricate projects with a lot of integrated items. If you look at the elevation on this project, you look at this section right here, that looks pretty flat, okay? But on these projects, you get a lot of curved panels. If you look at the top, this building, that's the same building. It's actually got a lot of curved panels on it as well. And as you looked at that previous slide, it looks like it's all one color, one module. But you see, they actually went in on this project. If you look at this top row, there's 2 different colors on there on each one of those. So that whole top section there is 3 different color panels. Or in this project, it's actually different textures. So on these large complex C projects, you got to look for other drawings that include, maybe there's panel drawings, just because of the complexity of it, and that's what these ones represent. Other things that happen on these projects, we have a lot of integrated items. The manufacturers can supply you with sunshades that penetrate through the panels. This large gray area here, that's actually a large extrusion that is a light shelf. So at night, there's LEDs in there that operate with different color lighting. And also, you can have integrated windows. There's a curtain wall system back here, but there's also integrated windows on these projects. So a lot of things to look for on these complexity C, the higher end architectural projects. As you can see here, we got some hidden elevations again, a lot of fabricated panels that come and wrap around. And then your takeoff's going to be pretty complex. You'll be taking off by elevation each panel. You just can't say, for instance, if this wall was an example of one, you just can't say I have 50 panels that are 20 feet tall. You're going to be going in and taking off individual panels. So allow for a lot of times to do those estimates as well. Taking off your details, making sure you have all the details covered. You got to keep in mind you'll have curved details as well. On these projects too, there's a lot of extrusions. So those curved extrusions are a lot of added cost. any fabrications that have to be done to those extrusions are always more cost as well. So your pricing, you're going to be actually, if you notice, in this project, there's an 18-inch, a 24, and 24-inch modules. There's 2 different colors. There's smooth striated. There's embossed flat. So all those elements add to the pricing of the panels, and those panels all need to be taken off separately so you can get the correct pricing for those panels from the manufacturer. Because if you go in and just say, I have 5,000 square feet of 36-inch wide panel, okay, they're all the same, everything. Well, actually, at 5,000 square feet, maybe 1,000 square feet of smooth, 2,000 square feet of embossed. Oh, and I got some striated panels too. Oh, and by the way, that 1,000 square feet of smooth, that's actually 500 square feet of one color and 500 of another. So take off those different elements separately. So as you can see, you wind up with multiple colors on these buildings. Window systems that are integrated, louvers that are integrated. This project here actually has like a chameleon color. It changes color as you walk around the building. So in those kind of projects in metallics and micas, you have to run those at one time. The coils have to be, they're directional finishes. The metal flakes in the panel and the finish actually stand up. One run may be different from another one. So always keep that in mind if you're working on a project like this, that you have, if a different run, have on another elevation so they're not side by side, so it's not as prevalent. All right, and then just to recap, estimating, account for your waste. Keep those doors, windows, openings, that sloped roof, the overlaps. Pay attention to the details. Dig into the details. Make sure you got everything covered. Make sure you got those hidden details, those bent panels, those curved panels. And then know the site. Is it going to be a project in New York City that you can only bring a truckload in a day? Or is it a project in the middle of Texas that has a 100-acre field around it? You can lay panels around and bring them up to the site. But keep in mind, those panels come out with different dimensions, different sizes, and labeled differently. You got to keep your sites organized as well. So building type A, this is your low-rise, pre-engineered buildings, pretty simple, basic projects. Then we get into B. This is a little bit more complex, your industrial style, minimum penetrations, mostly vertical panels, a few horizontal. And then building type C, this is your high-end architectural projects. Mostly horizontal panels, a lot of penetrations, integrated factors, extrusions, louvers, sunshades, windows, the list goes on and on. They're very complex projects. So I'd like to bring the other speakers up. Just pointed out again that this was an AIA accredited course, but we are opening up for questions. Just please, if you have a question, raise your hand, stand up. We'll come around with a microphone so we can hear you. Is there any questions at this time? We're all experts. Has anybody out there, show of hands, who have quoted metal buildings in the past? I know my back row guys have, you guys have. I was talking to a couple gentlemen, they have a couple projects coming up. So is this, most of you guys are looking at trying to get an understanding of what the market is, see if it's something you want to get into? Sure, one moment, sir, let's get the microphone up here.
Here comes Mr. Mike.
I'm not really familiar with when insulated metal panels really came onto the market and people started designing buildings with insulated metal panels.
Yeah.
Go ahead.
So in the U.S., probably early 80s was the first, going far back in the cold storage business, they've been used variety of different kind of panels, from panels that were filled with cork to all kinds of, those burned really well, by the way. Going back in those days and moving forward into foam panels, I would say we've been really trailing Europe, because insulated panels in Europe, if you go there, the majority, and I'm not a larger percentage, the majority of roofs in Europe are insulated panel roofs of some kind. whether it's a panel roof with a membrane over it or whether it's a metal roof. So Europe, I would say, probably a good 10 years ahead of where we are from an acceptability standpoint. And I think it's because they just build with a lot of steel to begin with. And I think in the U.S., we've been lagging because we're familiar with other materials. I live in Southern California, so we're tilt concrete all day, tilt concrete buildings everywhere. So, and we're still stud framing houses. Even though we have these things called termites and termites will eat those houses, we're still lagging where you could get a fully engineered metal stud home that will never have termites, but we're not building that way because the U.S., I think, is lagging. So insulated panels started in the 80s, really Jay Smith with Metalsman probably remember even in the late 90s, there was only 2 or 3 insulated panel factories in the entire country that were doing what we're doing now. And you go to Europe and you go to Italy and there's 40 lines in Italy alone running insulated panels the way we do. So now we're catching up, but I think starting really in the late 90s, real adoption started. And what's driving it in the US now is code. Insulation codes, when you got to get to an R40 in your roof assembly, we can do that easy enough, all the manufacturing do with a 5-inch panel. But if you try and stuff R40 with the fiberglass up there, it's a lot harder to do. So what's driving the codes what's driving the industry in the U.S. is code, and I think it's just forcing a lot of the industry into a new area. So so I'd say probably just the last 20 years really where it's really started and it's starting to gain some momentum.
And what about for in residential?
Yeah, even lagging even further behind.
Yeah, because there's a lot of room for growth in that.
Yeah,
Wow.
big time. We're seeing some residential now in Canada. Obviously, colder weather. Our product makes sense if you're going to insulate the building. If you're going to build a tire shop and you're never going to insulate it, our stuff doesn't make a lot of sense. But if you're going to insulate the building, our stuff makes sense. So if you're in cold weather or hot weather where I live, it makes some sense when you're going to insulate it. Otherwise, it's not really cost effective to use our stuff unless you're going to be temperature controlling the building.
Sure.
One thing to keep in mind too is that you're putting up a complete system for the exterior. You got the air and vapor barrier, the water barrier, the insulation. It's all one panel, up, done. Limits the trades for opportunity for errors. Another question's here in the back.
I have a question. So what is the adhesion method when you're extruding the panel? And the second question would be, if you're in a high wind, say like this hurricane coming up, would you suggest a heavier gauge metal in those areas?
Yes. So when I talk about extrusions are, say for instance, a starter strip that the panel actually sits on. You fasten that starter strip on the wall, then the panel rests on that. So you're not extruding the panel, it's just the extrusions are used as flashings.
You're talking about the manufacturing of the
The
panel
manufacturing
itself?
of the panel itself.
There's two ways a panel's manufactured. You can laminate panels together, which you take a board stock piece of urethane foam or styrene foam, and you actually use adhesive and you glue it together. You put it in a press, you put it together. Some panels are made like that. A lot of architectural panels are made like that. Most of the manufacturers that are here, we manufacture in a continuous line process, which means we take rolls of steel, run them through roll forming, and in a continuous line process, we lay the foam down in there as a liquid or a froth, and it bonds to the facings of the steel. There are some bond enhancers that are in there, but really what you're doing is you're bonding the foam itself to a special primer that's on the backside. So in our case, you're actually making the panel as a single element, and the foam is actually put into the panel in the process, then it's cut. Really, if you look at our lines, 300 or more feet long, and when we say that we don't make one panel well, it's because we've got to run out a whole lot of steel all the way to the end of our line before we get to our saw where we cut our first panel. So at my plant, I think I have to make a 250-foot panel to make a single panel. It's just the nature of the manufacturing, the way we have to run steel through the line. So the process, for the most part, when you're running mass quantity panels, is going to be what's called a continuous line, where you're putting the foam in as a liquid. And then there are some architectural panels that are laminated. Jeff, you can catch Jeff afterwards. He did that for a living for a very long time over at Benchmark. So, did that answer your question? Okay, and we got one more up here, Jeff.
One more thing he brought up. You know, you talked about the hurricane, the high wind areas. Yeah, you're going to have heavier gauge skins. You're going to have narrower panels. Your support systems are going to be closer together. That's when I talked about the loads and so forth, to look at those structural drawings, see what the design loads are for the project site. And that's how you determine to make sure that the face elements, the spacing of the structural is correct and so forth.
Yeah, and it's a great point. I would just say, rely on your manufacturer and ask them for their engineering calcs. You know, corner zones, edge zones, the middle of the wall is different from the corner and edge zones. The higher you get, the higher the wind loads are. So rely on the manufacturers. They're going to tell you, and it really is going to come down to fastening. It's going to come down to fastening. And this is another good part. RC just whispered this to me. One of the things in really, really high wind areas, especially hurricane zones, you may be required, it's a big labor deal, is having to go back on the backside of the panel and back fasten with fab locks, some kind of an expansion fastener on the back. And that's where you have to pre-drill and you have to put those in. So especially if you guys are familiar with FM, factory mutual rated projects and things like that, a lot of back fastening is required in high wind areas, and that can really, really add up when you start talking about your labor. So just be aware of that.
I have a couple questions. I'm an HVAC guy, so this is all brand new to me. The complexity A, B, and C, are those is that architectural talk? Is that, I mean, I've never heard of that.
We kind of created it for this presentation to try and get an idea of the complexity of the types of jobs, where a complexity A might be a pretty simple box. Complexity B, maybe you have some different wall surfaces and roof surfaces, roof planes. And in complexity C, we get into things like Benchmark and Centria does with radiused walls and integrated windows. And just to give you an idea that not all IMP jobs are created equal, that there are some jobs that when you look at the drawings, you can decide for yourself whether your company wants to go after that or not. Just by looking at drawings, you can see when you start seeing walls being curved and things like that, you may decide that it's outside of the capability of your company. And that's kind of where we're trying to give you an idea that RC was talking about some jobs that maybe kind of entry-level jobs for someone that wants to do some IMP. Brad's talking about some stuff that really you may not want to go near until you are in it for a while. Yeah.
Another question. When you're running the panels off your machine, how many feet can you run a minute with these IMPs?
It depends on the thickness. Thickness of the panel. Thinner the panel, the faster the line runs. Thicker, so a 2-inch panel runs at a certain speed. Each manufacturer has a recipe for their foam and line speeds, and it really, basically, thinner the panel, the faster the line runs.
Yeah, the 24 gauge would run quicker than the 22 gauge.
Gauge really has no factor. It's normally thickness. You got to allow the
thickness
foam,
of the panel?
Yeah, the foam time to cure.
Okay, gotcha.
The gauge of the facings really doesn't affect very much.
Okay, thank you.
Yeah.
Any other questions? Over here, one moment till he catches up with you. He's got to run.
On your horse, Jeff.
Do you have various types of finishes you can put on IMPs, imitating other materials other than steel? You know, like CMU or stucco or brick or wood. And the second question is estimating. So do you have any online software estimating tools? Do any of the manufacturers have that? Or do we call you specifically for various projects?
So first question with finishes, there's actually an example in the back of a textured finish that is similar to stucco. There's also the ability to do something with paints to make it look like zinc or give it a wood grain appearance. So there's paint finishes and other coating systems out there that give you that appearance of natural substrate or substance. As far as the estimating software, we don't have anything personal. There's multiple online or on-screen softwares out there. I know FL Crane here in the back has one that they used and customized very well, but there's multiple systems out there.
I think as a general rule of thumb, if you're down on the trade show floor and you see a paint manufacturer and he has some type of a paint system that's available for metal, all of the manufacturers, we can do something with the available paint systems that are out there for any type of metal surface. So I think that if it's available to be coated from a metal coil coater, the only thing I would say is limitations from the insulated panel side. Again, speaking generally, lighter colors good, dark colors bad. That's just a real simple way of putting it. So normally, light colors are popular for us. We sell a ton of white because people are looking for energy efficiency out of our stuff. We will not sell you a black panel. I told you earlier, with enough time and money, we'd sell you anything, but that's not true. We won't sell you a black panel because it's a really bad idea. So you're just going to have you talk to the manufacturer because there may be some length limitations and things like that when you get into some really sexy stuff, but the manufacturer will be able to tell you.
Can you emboss a grain?
Yeah, absolutely. Absolutely. If it can be embossed, if it's something can be done in metal, then we're likely going to be able to do it. Yeah.
One more question. All these three types of buildings, does they require some special certificate, maybe for fire, like NFPA 285 or similar?
So I think all of us have our own different fire testings, NFP 285, whether it's, the category, as we said earlier, category A, that's just a type of building. You'd have to see what the codes are for that area to make sure that you got the correct testing and everything necessary. But the manufacturers will be able to support you with their staff to come up with what we have done for testing.
I think in a general statement, all manufacturers, U.S.-based manufacturers, have testing required for U.S.-based codes. Now, when you get into things like Miami-Dade and things like that, specific local stuff, check with your manufacturer. But we all sell panels all over the country, so we all have those testing that are required by code. By the way, one of the things we do commonly as part of the Metal Construction Association, the IMP Council, we all get together and we discuss things like that, code-related issues. That's one of the reasons we're members of this organization, is we try and stay on top of the codes and standards.
Questions back? He'll be there in 1 second.
Good, thank you.
Wave your hand around, he'll find you.
Oh, we got him, okay. They're making me work out today. Oh, sorry about that. Just took out a briefcase. There you go, sir.
My question is on insulated wall panels sealing to the face. Most profiles you can seal to the face, like an EPDM roof or something like that comes up, and the proper way is to tuck behind the siding, but sometimes you have to face fasten. How do you do that when the insulated wall panels, the sealant is usually 1 to 2 inches back there?
I can take a stab at it. So couple things. One is, where is the vapor barrier and air barrier on the building? If it's a commercial industrial project, normally that's on the inside of the building. So you're going to put your sealant on the inside joint. Most of the manufacturers have a double tongue and groove. So it depends on where you're going to establish the air and water barrier for the building. If it's on the liner side, then yeah, you're sealing the back side of the panel, you're sealing the interior joint, and then you're pigtailing all that sealant together so that you have you create a single seal. If it's a cold storage building or some weird places, I shouldn't say weird, unique places like Alaska, things like that, where you have an inverted condition, you may be sealing both the inside and the outside because your vapor barrier is going to change during the year. It becomes warm on the inside of the building, so the vapor drive is different. So to answer your question, it's wherever the architect or wherever the general contractor is establishing the air and water barrier for the building. Normally, for commercial construction, it's on the liner side of our panel. So you are sealing against the back side of the panel, you're sealing the inside of the joint, and you're tying all that together. You're having to pigtail all that sealant together to create all of your areas, seal off all the areas where air and water could does that answer that question?
No, what I'm talking about is to keep the system watertight. Let's say you have an EPDM roof and you have it tying into an insulated wall panel, and the insulated wall panel accidentally got put on first.
Okay.
So you can't tuck up behind it, which would be the proper way to do it. And then we have to try to seal to the face of this insulated wall panel.
Yeah.
But no matter where that sealant is, it's not on the exterior?
We may, let's take that question. It's a more complicated detail, clearly, when you're trying to take an exterior EPDM and you're trying to tie it to the inside face of the wall. But I will tell you, every material has that challenge. Because if you're establishing the air and water barrier on the inside of the building, you're gonna have the same problem, whether it's a stucco building or whether it's a whatever, if it's Tyvek wrap or whatever, you gotta find a way to tie that to the roof. There's ways to do it, it's just a little more complex detail. And I think most of the manufacturers can work through that in the detailing process, shop drawing phase. We can work through that. And this may be the last one, Jeff, because we're right at time.
For your continuous process panels, what's the largest size that you can make?
It's going to be manufacturer dependent. And it's also not what we can run, but what we should run and what you want to handle. We've run in excess of 60 feet for large cold storage projects. I know Metal Span's done that as well. It's just that might not be the best idea. Depending on the color and depending on the thickness of the panel. So big, thick panels, 6-inch panels, white, we can make them pretty long. For you, from an estimating standpoint, is can you get them to the site? 48-foot truck is typically what we ship on. You can usually, in the US, you can overhang a little bit. So let's call it 50 feet, kind of a general rule of thumb. When it gets more than 50 feet, it gets a little trickier. And the job site, make sure your access roads to your job site could take a 50-foot panel. We've done some jobs where the truck gets there and there's just no way to get them up a road or whatever, so it gets a little bit more challenging.
And just to,
so we can make them longer than you want them, I guess, is probably the short answer.
Recommended 48, 50, but you can do 60 if you have the proper
max length, light colors.
capabilities.
Yeah.
And then for the, I know this isn't your business, but for the laminated panel systems, you said like the batch process, what is typically the largest size they would make also?
30 feet. I missed
That's for laminating panels.
Well, they glue them together. You said
That's kind of probably different for each manufacturer.
shorter.
It's based on their limitations of the equipment. You know, what, 16 foot? I don't know if you get any much longer than that.
So when you're laminating panels together, you're going to have a mold of some length, and that's going to determine the length of when you're laminating panels. Your presses are going to determine your length. Continuous lines will typically always be able to make longer panels, and presses are going to make, I would say, more custom type material in shorter lengths.
Okay. Thank you.
Yeah, they answered that pretty close. Just a rule of thumb for a structurally laminated panel, our standard would be 24-foot max. You could go to a special 30-foot max under the right conditions. Anything above that is going to have limitations. Okay, well, I'll tell you what, questions and comments are a very integral part of this presentation, so we thank you. At this time, I'd like to say to RC, Kim and Brad, thank you very much, and thank you for attending. So I hope it was worthwhile. We'll be in the back, and anything else?